What if I told you that the most powerful AIs in the world, the ones we interact with every single day, all share a secret, crippling flaw, a kind of amnesia? Well, today we're diving deep into a new architecture called Hope that might just be the cure, and it could change absolutely everything. So, what is this big secret, right? What's this memory problem that plagues every single powerful AI we use, from the chatbots we talk to the models that generate incredible images? Plain and simple, it has a form of amnesia. You see, once an AI model finishes its training, its knowledge is pretty much frozen in time. It's like taking a perfect snapshot of the internet in, say, early 2023, and then never letting it see a single new thing. If you want it to learn anything else, you have to do a complete, incredibly expensive reboot, which, get this, often forces it to forget stuff it already knew. And this gets us right to the core of AI's memory problem. Researchers have actually compared this to a condition in humans called anterograde amnesia, where a person literally can't form new long-term memories. The AI is just trapped, unable to truly grow or evolve from any new experiences it has. There's a technical term for this, and it's as dramatic as it sounds: catastrophic forgetting. Seriously, imagine you spent months learning to play the guitar, right? But then, the moment you learn one brand new chord, poof, you completely forget all the old ones. That is the exact challenge that has been holding AI back for years. So why does this even happen? Well, to understand that, we've got to look under the hood at the architecture that powers just about everything you've heard of, models like ChatGPT and Gemini. It's called the Transformer. And while they're incredibly powerful, they are, at their core, these frozen giants. This comparison just lays it all out perfectly. Over on the right, you've got the human brain, which is in this constant state of learning, growing, and adapting. But on the left, you have Transformer AIs. They're static. To learn something new, they have to be taken completely offline, rebuilt from the ground up. True learning on the job is just impossible. Okay, here's a fantastic analogy to help you really feel the problem. Think of a standard AI as this one giant skyscraper. Now, if you want to ask it a super simple question like, hey, what's 2 plus 2? The entire building has to light up. Every single component, every employee on every floor has to activate. It is massively, ridiculously inefficient and burns a colossal amount of energy. But what if there was a better way? A totally different way to build this thing? Well, this is where the Hope architecture comes into the picture. It's a new, brain-inspired model that's designed not as a static building, but as a dynamic, constantly learning machine. This table really gets to the heart of the innovation. You see, transformers use something called self-attention, where every piece of data has to look at every other piece of data. That's why its complexity is quadratic. As you add more information, the cost just explodes exponentially. But Hope uses something called nested optimization. Think of it more like a series of smart feedback loops that are all learning at different scales. This keeps the complexity linear, which means it scales efficiently and predictably. That makes continuous learning not just possible, but actually affordable. So let's go back to our city analogy. If the old AI was one giant, inefficient skyscraper, Hope is more like a city full of specialized neighborhoods. If you have a math question, it only goes to the math district. A history question, that goes to the history district. Only the relevant experts get activated. This is a concept called sparse activation, and it's dramatically faster and more efficient. And the core of this whole system is something called the Continuum Memory System, or CMS. And this is where it gets really, really cool. It's directly inspired by human brainwaves. It has different parts that learn at different speeds. Level 1 is a super fast learner, kind of like our short-term attention, handling things on the fly. But Level 3 is a slow, deep learner, consolidating core knowledge over millions of interactions, just like our long-term memory. So here's the crucial takeaway. Hope is never done learning. It uses what's called a surprise metric. If the AI sees some new information that contradicts what it thinks it knows, or that it just can't predict well, it flags that as surprising, and that triggers a learning update, right then and there. It's literally training its own brain, in real time as it's talking to you. Okay, so that all sounds incredible in theory, right? But does it actually, work? Well, let's take a look at the benchmarks because the results are pretty staggering. First off, let's just talk about context. That's the amount of information an AI can hold in its working memory at one time. For Hope, that number is an insane 10 million tokens. Now, to put that into perspective for you, that's like reading the entire Harry Potter series and still having room for the Lord of the Rings trilogy afterward. And it doesn't just hold all that context. It can actually use it with incredible precision. Just look at this needle in a haystack test. They hide one tiny piece of information in a massive document. As you can see, at 1 million tokens, Hope finds it with over 95% accuracy, while standard transformers are already starting to fall apart. But now look at the next row. At a mind-boggling 10 million tokens, transformers just completely fail. They can't do it. Hope's performance? It's stable. It's just a monumental leap in capability. And this bar chart? Wow, this really says it all. On tasks that require an AI to learn new things over time, you can see the performance of a standard AI completely collapses. That's catastrophic forgetting, right there in front of you. But look at the bar for Hope. It retains almost everything it learns. It's performing incredibly close to the theoretical maximum. For all practical purposes, it has nearly solved the forgetting problem. So what does all of this actually mean? The implications here go way, way beyond just building better chatbots. This really points to a future where AI is no longer a static tool, but a living, evolving partner. In fact, the creators of Hope themselves describe it as a direct precursor to the kind of AI we've only seen in science fiction, like in the movie Her. An assistant that doesn't just know facts about you, but actually grows and evolves with you through every single conversation. And maybe the most profound shift of all is this: that hard line we used to have between training an AI and using an AI, it's dissolving. With an architecture like Hope, the model is always learning. It's never finished. Using the AI is training the AI. So here's why this should matter to you. This is what enables AI that can be truly personalized, because it actually remembers your past conversations and what you like. It means we can have AI agents that can genuinely learn on the job. I mean, imagine a customer service bot that gets smarter and more helpful with every single person it talks to. And because it's so much more efficient, it dramatically lowers the cost of running these amazing systems for everyone. And that leaves us with this one fascinating question. We've had powerful AI before, and we've had personalized software. But with this new ability to learn continuously without forgetting, we might just be witnessing the true dawn of a persistent, evolving, and truly personal AI.